Thanks for the introduction. Welcome everyone and thanks for joining us today. I'm very pleased to be engaging with you today. So we will talk about the opportunities brought by the neutral atom quantum computers developed by Pasqal. The talk will be divided in three. Should I point there? Okay, perfect. So the talk will be divided in three sections. The first one will be an overview of Pasqal. The second one will be a presentation of our quantum solution. And we will finish by a presentation of some use cases. There are some slides with a lot of details. I won't go into all of the details, but I will instead focus your attention to the main information. So this first slide is quite interesting because it's a good summary about who we are and what we are doing. We are a full-stack neutral atom quantum computing company, and we are working with more than 40 clients from all over the world. And we have already proved that we are able to handle more than 1,000 qubits. Some of the brightest minds of the quantum fields are working at Pasqal. For example, Alain Aspect is the co-founder of the company, and Alain Aspect has been a laureate of the Nobel Prize in Physics in 2022. And to paraphrase Alain Aspect, I would like to say that what is not stated as impossible by the law of physics is therefore possible, even if it's really, really, really complex. So then later it's just a matter of resources and a matter of engineering skills. That's why at Pasqal we are blending science and engineering. And this slide shows that we have a global footprint working with clients from all over the world, and we have offices to support their quantum development, including offices in Japan, in Tokyo. Speaking of clients, I would like for you to focus on the first line of this slide. This slide shows that we are working in a wide range of industry, from pharmaceutical to aerospace. And on the first line, you can see some clients that have purchased a quantum processes unit from Pasqal. So we have sold a quantum processes unit in France, one in Germany, and one in Saudi Arabia. And what is interesting is that we have already delivered the quantum processes unit sold in France. So the first section could be summarized in those key takeaways. We are a full stack company, really focused on achieving as soon as possible quantum advantage. We are working with more than 40 clients from all over the world, and we have already sold 3 QPUs and delivered 1. On the second section, I will focus on the quantum solution developed by Pasqal. And I would like to start with our technology. We are leveraging the technology called neutral atoms. And the key words regarding that slide are optical tweezers. Indeed, we are using laser beam to trap and to position in space individual atoms and to encode quantum information. And this laser beam could also use to change the level of energy of those quantum systems, and therefore to imply quantum phenomenon like entanglement or superposition. And we have already showcased our ability to handle large qubit system. We showcase that we can work with more than 1,000 qubits, and we have a clear path toward 10,000 qubits. On this slide, I wanted to present that and to insist that we are a full stack company. Our commercial QPUs propose 200 qubits, but what is important here is that we are optimizing the software stack on top of this hardware. And that's really key in order to provide solutions that are valuable for our clients. So we are providing the full spectrum of quantum computing needs, from access to cloud-based infrastructure to turnkey solution or to R&D support. And our devices are really easy to set up. They are kind of plug and play. They are working at room temperature, and they are working in standard environment. And what is really important also is that they are really frugal. They do not consume a lot of energy. This supercomputer, quantum computing supercomputer, is consuming the equivalent of 4 hair dryers. So it's really, really low regarding classical supercomputers. On this slide, I am comparing some technology and benchmarking neutral atom regarding those technology. I won't go into the detail regarding the number because it's difficult to have numbers that are coming from benchmark that are standardized. But what I would like to emphasize that we are believing that neutral atom quantum computing will be the first technology to achieve quantum advantage. There are several reasons for that. Some of them could be long coherence time, scalability, for example. But one reason that I really appreciate is our capability to rearrange the qubit system in 3D. And it's really neat if we want to encode natively some specific quantum algorithm, for example, graph-based problem quantum algorithm. In the previous slide, I haven't talked about quantum annealing. There's two main reasons for that. The first one is that quantum annealing is not a general purpose quantum computer. Often they focus on specific optimization. And at Pasqal, we are really focusing on general purpose quantum computing. And the second reason is that within the quantum computing community, quantum annealers are quite challenged regarding their capability to reach quantum advantage. We are also often asked to compare Pasqal to the other player in neutral atom quantum computing. Again, I won't go into the benchmark of the hardware and into the benchmark regarding the numbers because it's difficult to compare orange to apple. But what I would like to insist on is our track record regarding the market traction and the market fit. We are the only neutral atom quantum computing company to have sold a quantum processes unit to a corporate. And I think this is highly relevant. And this is possible because we are working with more than 40 clients from all over the world, focusing on industry problem and solving real-world problem. And this is possible because we are the biggest neutral atom quantum computing company with more than 250 employees. Everyone at Pasqal is focused on developing the best hardware and optimizing the best software solution on top of this hardware. And we believe that we will reach quantum advantage if we are able to mix two types of mode, quantum computing mode, one being analog quantum computing, and the second one being digital quantum computing with error correction for the long term. So regarding the roadmap, there are two key information. The first one is that we are perfectly on track to reach 10,000 qubits in 2026. And the second information, again, is to say that we are investing as much energy on the development of the hardware than we are investing energy on the development of the software. Because again, we are focused on solving industry problems. Here are some recognition from our partners and our customers. We have sold a quantum processor to Aramco, the biggest energy company in the world, $500 billion of revenue per year. We have already delivered our first quantum processes unit to the CEA. It's a big entity focused on the nuclear energy in France, more than 20,000 employees. And we have signed a partnership agreement with IBM in order to boost and to accelerate the development of hybrid computing for high-performance computing centers. So I would like to summarize this second section, talking about the main takeaway, saying that we are really focused on industry problem, really focused on working hand in hand with our customers to achieve specific quantum advantage, not quantum advantage that is relevant in a R&D or in a lab, but quantum advantage that is relevant for businesses. We are a generic purpose quantum computing company that is already industry ready. I will illustrate that in the use cases. And we are delivering results thanks to this indicator of our high market traction. On the third section, I would like to talk about the use cases, but let's start with AI and sustainability. Those two key trends shaping the future are real opportunity for us. First, on the AI side, we are developing the future supercomputer that will power the next development in AI. And we are already working today on quantum machine learning. And on the sustainability side, our technology are really frugal. We consume several hundred times less energy than supercomputer. And that's why that's key solution to address the high consumption that we are already observing in the AI ecosystems. Regarding the quantum algorithm that we are mostly working on, there are 4 categories: quantum simulation, graph-based problem, optimization, and differential equation, or partial differential equation. And again, this is possible to work on this kind of algorithm because they are specifically designed to be optimized on our hardware. Here are some use cases. I will present the 4 use cases. I won't go into the detail of those use cases, but I want to walk you through our process when we are handling project with our customers. The first step is really to understand what would be the mathematical model to express the solution of the use cases of our partner or clients. And then how can we define the quantum version of this model. In this use case, addressing aeronautics, we wanted to be able to present and to model small change of physical phenomenon. That's why partial differential equation was perfect. And we have designed a quantum algorithm called differential quantum circuit. And we have chosen this algorithm for its high expressivity, meaning that we are able to integrate a lot of parameters. And this part is really important when we are working on partial differential equations. That would be useful for industry use cases. And here the industry use cases was fluid dynamics. On this slide, we were working with the client for optimizing processes in power plants, in chemical plants. And the idea there was to understand how we can integrate maximum parameters. So we have used an algorithm called quantum extremal learning. This algorithm is really useful when we want to add higher dimensional maximal parameters. And we received really good feedback from our clients when we implemented this algorithm on a use case focused on optimizing chemical processes for, industrial processes for chemical plants. The third use case is in finance. On this use case, we were working with Crédit Agricole in France, and the idea was to focus on the task classification task, excuse me. And we use an algorithm called Q2B, and we were extremely pleased by the result. First result, the training time was the same than the classical solution used by our customers. The second really interesting result is that we observe a better interpretability, meaning that the results were easier to classify, and it's key for use cases, for example, in this situation, of anticipating the downgrade, meaning the loss of value of counterparties. On this fourth use case, we wanted to work with the optimization of satellite coverage. So for that, we use an algorithm called maximum independent set. And it's really interesting to implement this kind of algorithm in our processing unit because we can encode them natively. Again, think about what I said regarding our capability to position in space and in 3D our qubit. And this is perfect if we want to encode natively this kind of algorithm on an analog digital mode. This slide, it's really to talk to the quantum leads in this audience. It's feedback of our experience working with more than 40 global clients from all over the world. The first part I would like to insist on is to say that when you will start working on quantum computing, do not consider quantum computing as another innovation program. Find the intersection of the already existing innovation program we are working with or working on in your company and use quantum computing from the beginning as a booster. The second part, it's to understand that today we do not have really hardware agnostic quantum algorithm, meaning that if we want to work on getting closer to quantum advantage, if we want to solve a real-world problem, we have to use quantum algorithms that will be designed for specific hardware. So choose wisely from the beginning your quantum provider. The third point, it's even if you start with simple algorithm, if you want to federate people that are important in your company, you have to work on projects that are really close to production. You have to work on projects that are really close to your end users. And from that, you have to define from the beginning, even if you start with a simple project, you have to define from the beginning multi-year roadmap with an increase of complexity of the use case you are working on. And the third feedback is please adapt the level of communication you use when you talk with people from your company. It doesn't make sense to talk about quantum jargon. Sometimes it's better to just focus on the value embedded in quantum computing and to be sure that the communication is based on use cases and not based on the specificity of quantum computing. So I would like to finish sharing those perspectives. So Pasqal is really focused on solving a solution to address real-world problem. And those real-world problems are relevant only if they are implemented on real quantum processes units. And that's what we are what we are doing with our partners and clients today. And we have an extensive experience that is used to match the new use cases we are encouraging our customers to develop and also to extend what we have already developed. Our role each time is to be sure that we are de-risking your quantum journey, meaning that you will invest time, invest energy in building quantum knowledge, and our role is to share our experience in order for you to de-risk your quantum journey. And from there, we can work on getting closer to quantum advantage. Again, not quantum advantage for topics that are only from R&D, but quantum advantage for your specific businesses. Because at the end of the day, nobody really cares about what is a quantum computer, or what kind of quantum computer you will use. What we will really care is the value we will provide when using these quantum computers. So I would like to thank you for your time. And I will add one information. I have recently relocated to Japan, so I will be based in Tokyo. And my role is to help the development and the integration of quantum strategy for company working on harnessing the power of quantum computing. So I will be more than pleased to support you in your development and in your quantum journey. So feel free to reach out after this talk or by email. Thanks for your time. Arigatou gozaimasu.
Thank you. I'm afraid we don't have too much time, but we do have some questions. I'll just throw them all in to see which ones you want to answer, JC. So the first one is, how does your hardware compare to QEra? Another one was, why is connectivity 1 to 20 instead of all to all? And then the third one was, what can be achieved with such slow clock rates and so few gates? But maybe you can touch on some of them as you feel free.
Yeah. So the recurring question is really, Pasqal, regarding the competition. And again, I don't think it makes sense to spend too much time on the number. There is not today benchmark validating how we can compare the fidelity, how we can compare the result to specific algorithm. So what is important for us is really our market fit, our market traction, and the feedback from our customers. And I think the best way to answer what are the differences regarding the competition is to show our backlog of sales. We have sold 3 quantum computers. We have delivered 1 quantum computer to a client in France, and we have sold 1 quantum computer to a corporate client. That is extremely relevant, I think, in the computing space.
Thank you. Excellent.
Thank you for your time.
Thank you, JC.